Good afternoon, everyone, and a very warm welcome to all of you. Thank you for joining us today for the University of Nottingham Masterclass, Designing Sustainable Housing. This is Dishanka Huja. I'm the Client Engagement Specialist at Study In, and I will be moderating today's session. At Study In, we support students in exploring global study opportunities and making informed academic and career decisions. Today's session will explore how sustainable design principles are transforming modern housing and how architects balance innovation, functionality, and environmental responsibility in the real world projects. So, it is now my pleasure to introduce our speaker for today, Professor Lucelia. She's the Chair of Sustainable and Resilient Cities at the University of Nottingham, Head of the Department of Architecture and Built Environment, and Deputy Director of the Energy Institute. Before we begin, a quick note for everyone. The Q&A option is available at the bottom of your screen. Please feel free to submit your questions and we will address them during the end of the session. So now, without any further delay, I would like to hand over the session to Professor Lucelia. All the very best.
Good afternoon, everyone, and thanks very much, Shanks, for the introduction. I'm going to just share my screen. All good? You can all see?
Yes, it's visible. Perfectly fine. Yeah.
Brilliant. So good morning, everyone. It's good afternoon. It's good morning for me. It's a beautiful day here in Nottingham. You see my background is a picture, but it's a picture of our central building, the Trent building, and that's actually the university campus, the university park in Europe. It's really beautiful. So I'm afraid I can't take you around the campus today, but you'll see some images through the presentation. So I'm going to start just by giving you a little bit of an introduction to us, to the department. As Ishang said, I've got three rows or three hats in this particular presentation here today. I'm head of the department for architecture and built environment, and I'm also course director for the March in Architecture and Sustainable Design, which is why I'm talking to you about sustainable design today. And I'm also one of the leaders of our University of Nottingham Energy Institute, because it's aligned with my expertise. Now, the University of Nottingham is the top 100 university in the world, and so is the department. We have been top 100 for a number of years internationally, so both in the QS World Ranking and also in the Times Higher Education Ranking, but we also top 10 in every single internal UK ranking, so we're very well placed. I also wanted to highlight that postgraduate students have voted us one of the top 10 in the UK for quality of teaching and experience that you get when you come here. We've got also first for assessment resources and second for engagement, third for skills development. So that's voted by students like perhaps yourself who have come and spent a year with us. And then we'll ask by Advanced HE, which is not us, so it's not our survey, it's an external survey. And you can see that they had a pretty good time here, which we want to make sure you would too if you join us. And particularly, we're really very good for graduate employment. So once you join us, you come out with a very high level of skills. And this the course I teach, will tell you about a bit more in a minute, is very much focused on sustainability, but across the department, we are very known for being a sustainability-driven teaching department and as well as research. I said I was going to show some pictures of where we work. So you can see here some of the buildings you would occupy if you're coming to study with us. This is part of our mini architecture and built environment campus. It's pretty beautiful. I say all the time, it's such a privilege to work in a park. So my office is in that old house on the top left. Our main teaching spaces are on the top right building, which is just across the courtyard from my office. What you have in the middle there is a summer house, which is it's a Victorian beautiful house associated with the house at the top. And then to the right of that, the creative energy homes, which I'm going to talk a bit more about today, which are energy efficient, sustainable housing that we built on campus to practice what we preach. And then at the bottom, you have some images of just surrounding us. It is just stunning, and is one of our biggest selling points because It's so wonderful to walk amongst trees and the greenery, and the bunnies. It's full of bunnies. I should have put a picture of bunnies, but I didn't. So I said we're really known for sustainability. I came to the UK to study sustainable architecture, and I came to Nottingham because Nottingham has always been, or at least since at least 1980s and the early 90s, known as the top university for sustainability teaching in the UK and in the world. So in the 1990s, Brendan Robert Vail, who are quoted here, came to work in Nottingham because they said it was the place that took sustainable architecture the most seriously in the whole of the UK, and they were at the time they were the first people to build the autonomous house. So you can see the picture on the right here. So they built their own house to be completely autonomous from the energy grid, from the water grid, and that was really super innovative. Nobody was thinking about sustainability back in the 90s. It wasn't a major concern. So they were leading, and they established a very strong reputation and a strong baseline. And the reason why I came to Nottingham is because I found out about this, and I've been here for now 22 years and delighted to stay. Love the place. It's a great place to be. Now, as one of my roles is leading the March in Architecture and Design, I thought I'd just tell you a little bit more about it. It's really about bringing environmental considerations to the forefront of architecture design. Now, I imagine a lot of you might be thinking, oh, it's all about energy or putting renewable energy on the roof. It's about photovoltaics, and it's not. Because sustainability really starts with the designer, with the design skills that are needed to make the buildings more livable, more energy efficient, that encourage a sustainable lifestyle before you can even think about energy. And I'm going to talk through an example today just to show you what I mean. This is an image produced by students from the 2011-2012 cohort. They were produced for a scheme called the Trent Basin in Nottingham, which at the time didn't exist. This project, alongside the other projects from the students that year, have helped to shape up the Trent Basin regeneration scheme, which is now fully developed. So if you look it up online, you'll find lots of information. And the council and the developers have made it a lot more sustainable and energy efficient because of the work that they did with us. We then also set them up as a community energy scheme in order to provide energy in an optimized way for the community. So it was all about the design of the houses, the design of the development, alongside then a provision of energy and renewable energy optimization. And I just wanted to put some words for one of our graduates for you. This is Abdu. You can read what he said there. He wrote some wonderful words online. So if you look him up and on his LinkedIn, you see some more information about how he experienced in the course, which is now, I think, maybe 11 years ago, so quite a while ago, and he's still posting about it because it really changed his life. Other graduates you'll find all around the globe. So we've got here Rong Xu, who's head of environment sustainability, a pretty big enterprise in China. Deepika, who's head of director of Hollis, and he was former head of sustainability at Price Myers in the UK. And Mauricio, who set up a very well-known architectural practice in Costa Rica, which is all about sustainable architecture. We have quite a lot of students from India that come and do really well. They either stay in the UK or they go back, and they might work in practice, or they might work in academia. So here, Meghna is working for Fosters and Partners, who a lot of you probably will know. Gayatri is working for Elemento. Elemento is really big in the UK, but she's working in the Indian office. You see, Meghna is working as an architecture and designer, while Gayatri is working as a sustainability consultant, aiding the design. And Jesus to the right, he was from Mexico, and he's now in the UK working for WSP, which is one of the largest consultancy in the world. Shafira is working in Indonesia, leading Mott MacDonald's sustainability office there. Sabrina is leading the lighting section in Arup in London. Richard Pawford is a partner at Cullinan Studios. All these guys have been through the course. They've gone back into industry in various areas, and these other ones here, they've been through the course and then gone back into academia. So they're doing PhDs, or they've done their PhDs and now working as professors in their own right. If you want to know a bit more or have a look at some of those students' work, there's a QR code here. There's a link as well. The presentation can be shared, and you can just go and have a look through, a browse through the projects. Not just this program. The Architecture and Beauty department has 16 core programs. That includes architecture in itself, which is in the UK is made of part 1, part 2, and part 3. So it's a very long program. Includes building engineering, which could be done in 3, 4, or 5 years, depending on the type of route you choose, as well as 7 postgraduate courses on specialized topics, including sustainable architecture. So it's a pretty big department, so you see a lot of it in the online exhibition. And to give you a really good view of the department, I also suggest you have watched a video that is, again, the link is here. There's a QR code. This is going to give you just a walk through the department in our end of year exhibition. This is from 2023, where the students spin up their work and then they talk about the work to practices. Typically, we get about 80 practice partners that come around and they offer people jobs based on the work they've done. They create the first interaction for them to go on and work together. So it's a pretty special day. It's coming for the next one is 18th of June. If you are in the UK, come around. You're invited. Now, enough of the department. I just want to start then talking about sustainable housing. As I said, I would have thought a lot of people might think sustainable housing is all about the renewable energy. That's what happens often. And often because of that, you also have maybe clients, maybe partners within your businesses that would not be keen to do it. They might be thinking it's just expensive. Well, we can do that later. It can be an add-on. And I often start my talks with this slide because at this stage, if you're not yet, I want you to panic. And I want you to panic because as a designer, you have a huge responsibility in delivering sustainability, but also in delivering a built environment which enables people to be more sustainable, to live more sustainable lifestyles. If it's too difficult to live sustainably or to have a lower impact on the environment, people won't do it. People will always take the easiest path. And it's very hard for humans to understand the impact that they will have 100 years from now. So the carbon emissions we experience now were released 100 years ago. So what we're doing now is going to impact not only our kids, but our grandchildren. And that's the thinking we have to have. And it's really hard for humans to engage with that. Therefore, it's down to us as designers to do a lot of the thinking for them and imagine what the future should look like. Now, this recognition that climate change and thinking of environmental impact in architectural design has really come a bit late. I told you in our department, we've been working on this for since the 1980s, really, which is brilliant. However, actually, the profession in the UK and the profession across the world has taken a long time to get here. Some countries are still catching up. And I know India is getting to a fantastic place where sustainability is becoming core to all design practices, but is that taking a long time to get to that stage? In the UK, it wasn't until about 10 years ago that the then RIBA president said, well, changes here. We need to start addressing sustainable design. And that's just, it's yesterday, isn't it? Because if you think of the buildings you're inhabiting right now, they will be maybe 20, 30. In fact, the house I'm sitting in now is 140 years old. So that's when we should have been thinking about it. And whatever you're building now, hopefully be inhabited in 140 years from now and needs to be performing well, and needs to be enable people to be productive and happy and healthy in your buildings. So yes, changes overdue, I would say. Changing should have happened years before this. But I'm delighted to say that we've been in the forefront of that and leading the way. Now, when RIBA recognized the need for sustainability, we worked together with them alongside some other partners to develop the RIBA Sustainable Outcomes Guide. That's a reflection of the Sustainable Development Goals and those that are more important or essential, really, for building design. So thinking through them all, as you can see on the left, you probably recognize them. So the Sustainable Development Goals, if you don't know them, they are ways of us addressing sustainability in 17 dimensions, right? It goes all the way from, yes, there is energy, yes, there's climate action, but also talks about poverty, or talks about hunger, talks about sustainability of communities. So it's a broad spectrum range of goals that we try to organize ourselves against. And building design is always being a little bit sidelined and just really focus on one particular side of that. So to the right of this slide, what you can see is the list of sustainable development goals, and then the list of RIBA sustainable outcomes that will recognize as being the most important ones to be addressed immediately as you're starting your design. So you can see this is not really about energy alone. Energy is important and is in there too, and I'm going to show you where, but it's really about a broad range of sustainability goals that we need to address through the designs that we make. So if I break that down a little bit to our next stage, you see at the very top, it talks about environmental sustainability, social sustainability, and economic sustainability. And some of those outcomes that are expected, they overlap. So some things are delivering across all three of those aspects of sustainability. Some of them are more focused on one aspect alone. If you look at the very left, the yellow one, that's called the net zero operational carbon. So it's talking about reducing the carbon that is emitted during the operation of a building. And a lot of that carbon comes from energy. So somewhere down those 9 principles down there that are listed, energy is quoted. So you're trying to make things more energy efficient. It's also responding to things, for example, trying to retrofit a building rather than building from scratch, so it can reduce your carbon impact. But you can see that that's one column that is very, very much very important, but it's not all of it. There's a lot more. When you go to the next column, then it's talking about embodied carbon. So if the left one is operational carbon, so when the building is uninhabited and in operation, the second one, the embodied carbon, is what is embodied within the fabric of the building. And that's really talking about extraction of materials, transport of materials, building of the building, as well as retrofitting over time, maintenance, and end of life. So we're also trying to reduce our carbon impact by choosing the right materials, by trying to not transport them all across the world, by trying to reduce the type of materials that we use and the manufacturing of them, as well as the way they are constructed on site and the way they're maintained over a long period of time. As we go through this, you see the next one is talking about water. And water is a big part of sustainability. And in some countries, it may be even more important than energy. And also it may be more a harder thing to deal with than energy. In the UK, people use 120 liters of water per day in average for showering and drinking and cooking, while the maximum we should be using really is 80. So in order to enable that to happen, we can't just go around and telling people, just don't shower. We as designers have to think, actually, you can shower, but perhaps we could use rainwater that we have harvested from when it's raining, and we have gathered in a tank, and we cleaned it up and made it for you to have a shower. Or maybe when you're flushing a toilet, could be reusing the water that was already used for the shower. So why do you need to use clean water to flush the toilet? So that's the thinking that the designer would bring in that would enable someone to just use the toilet or have a shower without necessarily having to think about the amount of water they have used. They can still reduce, but it would enable them to use water more sustainably. The next column talks about sustainability in transport and connectivity. So if you are designing buildings that are completely disconnected from the fabric, from the cities, or for the urban fabric, then you making people maybe drive. And if you're making people drive, and their services and their facilities and their work is not within walking access or within public transport access in such a way that is pleasant. So you also, it's pleasant, is safe. So if you want people to use public transport and to walk, you may need to enable them to do so by providing them green pathways, providing them shading, providing them a safe environment to walk through. So again, that's down to you as a designer to think that integration of your buildings, or thinking through the design of a whole community, or thinking through the design of a whole city. The next one, the first one in green, is all about land use and ecology. And perhaps that's another aspect of sustainability that a lot of you have thought about. So greening buildings, so putting plants on buildings or putting plants on the surroundings and the communities. And yes, absolutely, that's a big part of sustainability too. But it's not the only part. So thinking through the biodiversity net gains, thinking through how actually by having nature in cities, you can reduce the temperature significantly. So I don't know where you're coming from in India, but if you might be in a hot area of India, and if you are, you might be thinking, actually, my biggest problem here is that I need air conditioning. Well, perhaps if your area was greener, you would have a significant reduction of temperature. For example, under a tree canopy, you could have a 12 degrees difference, so lower, less than 12 degrees less than the temperature that you have measured on the concrete. And I'm not even talking the surface of the concrete, just the temperature they experience as a person. So yes, greenery is a big part of this. Now, the darker green is all about people, good health and well-being. And really, this is the core of all sustainable design. You're designing buildings that will enable people to live a sustainable lifestyle, but also to live healthy lifestyles, to be productive in their spaces, to be happy because they have views to the outside, because they've got enough daylight, because they are able to walk to and from, because they can actually plant maybe some of the food, maybe they have access to a garden, maybe they live in temperatures that are very comfortable without the need for conditioning. Maybe they have air that is fresh and is not polluted. So again, all those aspects of good health and well-being are really down to a designer thinking. Now, by doing those things, then you bring us to the next one, because it brings us to sustainable communities and social value. So this is about you as a designer enabling people to get together as a community, enabling people to interact, produce networks, to enhance community capital, maybe enable people to go to work because they might have struggled before, but maybe the way you connect your properties to the grid or to the urban grid would enable them to get to work more safely, and therefore they might get to work. So you're adding a lot of value to society by thinking those through. And the final one is about sustainable lifestyle costs. So this is about, again, thinking about sustainability from an economic perspective, thinking about how, one, you are creating more jobs, two, you may be building to a lower cost, three, maybe saving on energy, which may be saving money along the way. So if you think about lifestyle costs, you're thinking about from cradle to crate, all the way across the building design and delivery. What is the cost of that, and is there a return, maybe through productivity, maybe through lower cost on energy? So, having said over this, I'm going to show you an example of one particular house that was designed by our students with our support for a competition, and this is called the Nottingham House. So the Nottingham House was also sponsored by Saint-Gobain, which is a global company present everywhere in the world that produces and supplies construction materials, essentially almost across everything that we need for building design. Now, the Nottingham House stands for Housing Optimizing the Use of Solar Energy. And the reason why we're focusing on solar energy is because we designed it for the Solar Decathlon competition. This is a competition you may have heard of because India has hosted more recently. But back in 2002, it was created in the US. And it was about US universities coming together to demonstrate their houses could be produced that would deliver a affordable way of living, comfortable, healthy indoor spaces, enough supply that is self-sufficient, adequate provision of water and hot water, and have a net positive impact on environment. So that was the thinking back then. In 2000, in the US, this competition often will be displayed in Washington, D.C. So you can see, you probably have seen a few pictures from Washington, D.C. recently through Trump's posts. I'm not sure that's a good thing. But but for this one, you can see that these lots of houses are then built on the competition grounds and people can visit. Now, typically, you might get 100 universities applying to be part of the competition, but only 20 will be selected. It's called Decathlon because it has 10 different criteria that you have to fulfill. So there is a architectural design and how quality of that. There's a market appeal. Is it something that would be able to be sold in a real world? Is the engineering good? The communications, the affordability, the comfort within the house, the use of appliances, how is the home life supported in terms of sustainability, how is it integrated across a setting, and what's the energy balance. So energy is a part of it, but it's one part of it. There's a lot more to the competition, but it's pretty hard. There's 10 aspects to deliver which are really tough. If you imagine now, you would be designing that yourself as a student, and you would be building it yourself as well. And in 2010 was the first time that the solar decathlon came out of the US into Europe. It was the first one held outside the USA, and he was held in Madrid. And we applied to take part, one of 100 universities, and we got selected. So one of 20 to be selected to take it further. Now, the challenge we try to address, but the challenges, because there's many of them. The first one, and one of the most restrictive ones, I would say, is the envelope. So the size of the plot and the size of the house were very restrictive, because you couldn't have your house impacting on the neighbor. So you had to keep a free area around your house. And very importantly, you have to have a maximum height of 5.5. And that's including everything. So roof, photovoltaics, whatever is needed. The second challenge, you had 4 days to build a whole house, a whole functioning house, and you had 2 days to take it apart after the competition. Now, we were far too ambitious, and we said, actually, we want to do something that is very relevant to bring back to the UK. So we want to do a family house. And to do a family house, we're going to do it 2 stories. Now, is that why is ambitious? Well, it's ambitious because, one, we've got a height restriction, 5.5. 2, constructing a 2 stories house in 4 days is really hard. 3, it had never been done before. It was the very first time in the history of the competition when there was a 2 stories house. The other challenge that we set the students is that you obviously had to perform in Madrid for the competition, and that was in the summer, so it was very hot and very dry. But we also wanted to bring the house back to Nottingham, and coming back to Nottingham, we had to perform in the Nottingham summer as well, but in our winter. So very different climates, and very difficult to design for different climates like that. Beyond that, we also needed to make the house energy efficient, powered by the sun, because that was part of the competition criteria. And we told the students, let's go beyond that, and let's meet the Code for Sustainable Homes Level 6. In the UK, that's the code that dictates whether a house is zero carbon. So it's really stringent and very difficult to achieve. But we didn't stop there. We said, let's also make a passive house. And if you know, passive house is a German standard. It started in Germany, it has spread across the world, and it's all about making a house that is almost has no need for heating or cooling, just runs by itself. It is pretty healthy. It's very difficult, pretty stringent. It's all about the building physics here. We also wanted to make it a marketable house. So not only was 3 stories, but we also wanted to design it for high density urban living, recognizing that actually a standalone pavilion is not something that is very marketable. It's too, not many people have a large plot in the middle of nowhere that they can have a pavilion. Most people be living in the cities, and therefore we wanted to promote livability, well-being, sustainable lifestyle in a urban setting. So with all these restrictions, a maximum footprint of 74, maximum height of 5.5, being standalone for energy, meeting 2 energy efficient codes and the sustainability code, and work both climates. Goodness, there was a lot to deliver, but that's what we came up with. The Nottingham House, home optimizing the use of solar energy. I wanted it to call the Nottingham Madhouse, because really it was a madhouse to do it. Was crazy, but also the house was a modular house because we had so little time to build it. So how did the students respond to the brief? We worked in studio with them. So you're familiar with studio design and architecture. We gave them this brief, very difficult brief. They worked in small groups of 2 or 3 students, and they all came up with their own propositions. Once we judged the propositions and we decided which one was meeting all the criteria and it was buildable and it had all that we needed, we then brought the whole team together, and this is a team of both home students and international students, so students from all over the planet. I think we had 13 nationalities in the class, from British to Japanese to Indian, Chinese, Brazilian, Chilean. It was fantastic. In fact, that's one of the things in the UK. You actually get exposed to so many cultures. And I was myself an international student here 22 years ago. I came from Brazil, and I made some of my best friends today when I spent a year here studying. It changed your life. It changed the way you look at the world. It changed your horizons. I've been to India as a result to go to weddings and visit friends. I've been everywhere. You name it, Japan, the whole of Asia, Australia, Africa, more South America, more North America, because it really expands your horizons. So anyway, the students were there working together in a big group. We came up with a modular house because it has to be built very quickly. So it was made in 8 chunks. That's how they looked like. First, these drawings, by the way, are by the students. So when the student that won the competition in class had sketched the house as they imagine, in order for us to understand what they're trying to bring across. So keep an eye on those, because you will see them turning to life later. So firstly, we made panels, and then we brought panels together into modules. Then the modules were craned into position, and then we would put the roof and the PVs and the cladding beyond that. And the idea is that they would have mirrored master plans, mirrored houses, so you can do a whole housing development. This is an image of all the elements that would have gone into the walls and into each one of the modules. Now, very importantly, their response was a family home. So the idea of having 2 stories, something that is part of an urban setting, it felt that was really appropriate to us. That means the house was designed as a 2-bedroom house, which again was unknown of in the competition, but with a special focus on social interaction and a social living that brings that idea of sustainability to the core. We also gave them a site in Nottingham to design for, so they had to think about how the house would fit into the urban setting that I discussed. So this is a sketch of a part of the site where the students thought, actually, if we do an L-shaped house, we can mirror, and everyone can have their own courtyard, and then they can have common gardens as well, and they can have common gardens for planting, which you can see at the bottom of that. So the community everyone has their own space individually, but the community can come together and plant food that they can eat. And within their own courtyards, they designed a rainwater harvesting system underneath a decking system, and then small planters where people could plant, obviously not over their food in their own private garden because it's not large enough, but they could plant things like peppers and tomatoes and carrots. And the thinking was that if kids engage with their planting and engaging with knowing where the food comes from and have access to healthier food, they also have a healthier lifestyle and healthier eating. Now, obviously, a big part of this was also delivering comfort, sustainability, and energy efficiency. In order to do that, we thought actually we asked the students to design different strategies for the summer, for spring and autumn, and for winter. So they had to think how the house would be alive and responding to the environment, how people would be interacting with the house to make it work over the whole year, over the whole day, in the evening. So when you're designing something that is calling you design a sustainable housing scheme, it needs to be alive. It needs to be changing constantly throughout the day, throughout the seasons, throughout the week. Maybe weekdays and weekends are different. So if you're ever doing your sustainable design, you will be encouraged to be working through different responses for different conditions. Now, their response was obviously the very compact house. A compact house really helps in terms of energy efficiency and sustainability, using less material, but you also enable the house to keep heating and cooling in without losing it through the walls. And that's a section through the house. You can see that right in the middle there is a leftover shaft right on top of the dining room that brings daylight, but also enables us to install cooling, evaporative cooling from a tree. I'll talk about that a little bit more in a minute. So you can see us collaborating, students, staff, everyone working together to bring this to a buildable level. Through that, we did a lot of performative analysis. So some of the students were doing for example, daylight analysis here. So they concluded that some more windows were needed or bigger windows were needed in different positions. Some were doing solar shading analysis, and then therefore we installed solar shading to respond to the analysis they have done. And then we calculated whether was enough with shading and the cooling enough to keep the house comfortable across through the whole year. So obviously we had to do this for Madrid and for Nottingham, and it's very difficult to do, obviously impossible to test it in situ. So we did auto simulations prior to building the house. And the response to cooling in Madrid, so I told you Madrid can be really hot and dry in the summer. So one of our professors specialized in evaporative cooling. So he designed a passive downdraft evaporative cooling. So you might be familiar with using an updraft in buildings. So when you talk about stack effect, like cool air coming in, gets warmed up, and it comes out to the top of the roof. Very traditional strategy. Some of your houses might even have it. Now here we're doing a downdraft. What does that mean? Well, the warm air will get warmed up at the top of the house, and you get in contact with very small droplets of water, so like a spray of water. As the water evaporated, the air gets cooled down. So evaporative cooling means the evaporation is extracting heat from the air. As the air gets cooler, it drops because cool air is heavier than warm air. As it drops, we design the windows on the perimeter of the house very, very well and thought very carefully about the size and position of those windows. So we would encourage that draft to go through all the spaces, encourage all the spaces to get cool. And we've tested that in through software analysis. So you can see here prior to building the house, a simulation of that system and how the code there will get distributed across the rooms. And you can see here a test chamber. So it's a replication of the middle bit when we then do the spray in the water and assess where we could get the cooling distributed. So this performative analysis is really important because it gives you the evidence you need to build something that is going to really perform. And you can see in the early test from the test chamber that the temperature from outside, which is the purpley pink color, it was much higher than the temperature inside with evaporative cooling, which is the bluer color. So the evaporative cooling really helped to reduce the temperature. We also said we're going to deliver against the Code for Sustainable Homes, but the one that I said is about sustainability and net zero carbon. But you can see that it's not just about energy. So it has this 9 criteria, 9 categories, and you had to respond to all of them. Some of them were easier than others for us, but we would achieve a 92.07, which would mean the house is a code level 6. So at least on paper there, we have achieved what we aim to achieve. And in the UK, we also assess the sustainability and energy efficiency of the houses through a standard assessment procedure. So this just gives us the number that we want to put in the energy side. Now, when it comes to passive house, which I mentioned earlier, then there is a complex spreadsheet that is all about the building physics. And that's where you can't escape because physics is physics, right? It's all about delivering as higher precision and the performance as you could possibly think of. Again, the students got into grips with calculating passive house, and the house would achieve passive house, although we haven't certified at the end. Now, then once that was all designed and the students designed to the high level detail, we went ahead and built it. To build it, we invited more students on board from year 2. There's lots of staff that were involved with various different expertise and support that were needed, as well as Saint-Gobain, who was funding the build, and their own staff and other partners that are all listed in there. So there was a lot of people brought together to make this happen. And Saint-Gobain's sponsorship was very important because they provided us with all these materials you can see there. So all these companies listed there, with the exception to DHL and Roger Bullivan to the right, bottom right, they're all part of the Saint-Gobain umbrella. And therefore we had access to those materials, and that goes through, photovoltaics or insulation materials or timber, which was what we decided to use to build the house. This is a picture of the house being built in one of our campuses here in Nottingham. It was an old TV studio, so we had a really big height and lots of space. So we used that space to build houses. You can see those that you can see there are students. a big part of the learning was actually how do you build a house that's energy efficient. So you can see there the walls are practically made of insulation. We had quite a lot of wastage because people were learning, but actually the experience was fantastic. The students got snapped off the best jobs straight away. You can see everyone working in various areas. So on the left, you can see buttons being fixed. On the right, you can see the cladding finalized and the metal, the metal finishing, trimming around the cladding. And obviously, through that, there was a lot of understanding, or the students had learned a lot about how design really turns into real life. So each little line you make in your drawing, how it turns into life. And now I'm going to show you a few pictures that has alongside that some of the images I told you about. So on the top right, you can see there one of the sketches the students had made right at the beginning to imagining how the panels will look like. And that's a picture of the panels being built. So you can see that actually, if you imagine it to a higher level of detail and if you really think it through, actually turns into reality quite easily. Now, before we took it to Madrid, we packed it up, put it on a truck, and took it to London, to the EcoBuild, which is now called Future Build, which is the largest sustainability in construction exhibition in the world. So you might even come one day to visit. We got awards there, but on the way taking the house there, we broke one of the modules. So the house was built in 8 modules, and one of them got broken. So if you see on the top right picture there, where the housing minister is visiting the house, there is a module missing. So we made a balcony instead for that purpose. It meant that we had to come back to Nottingham and build it again, the module. It was quite a bit of work, but eventually we made it to Madrid, and that's our site. We had a little bit of a problem. We got there, and it was, they realized that our house might have been a bit too heavy. And I will spare you the details because you were able to find some videos online where you see us crying about it. So I'm not going to tell you everything about the hard bits, but I'll show you the nice bits. Here the sketch from the students, and here's the real life house being built. Again, and a sketch from the students, and that's the house finalized, almost finalized, in readiness for the exhibition and for people to visit. You can see that the setting, so the house is the timber bed, the setting is really against the Madrid Palace. So it's a beautiful place to go. There was, I can't remember how many million people visit, but you see there were queues and queues of the public to visit, which of course made it slightly harder to keep comfort because it's a pretty small house, and we had 50 people going through the house, releasing their own heat inside, so it was very difficult to keep comfort. However, this is a picture of the passive downdraft evaporative cooling system I was telling you about. It actually worked really well. It kept the temperature down. So you can see there the performance, the blue line being the external temperature and the green line being the temperature inside the living room, the red in the bedroom. So this is without air conditioning. We brought the temperature down from that blue line going all the way to 42 degrees to actually being within the 20s, which is fantastic. So no need for air conditioning, just good design associated with passive downdraft evaporative cooling. This is the PV generation. So the predicted generation was 130 kilowatts hours. We produced actually 141. So we want to over the capacity and produce more energy than we needed for the duration. We can see some images here of the generation is in blue. The predicted, the actual generation is in green, and the purple line at the bottom is the demand. So we can see how much more energy we produce than the actually needed for the house. And it's a picture from above of us in front of the house when it was all ready to go. Now, once the competition finished, we needed to bring it back to Nottingham. It took us a while to convince our university to actually have it on site, but eventually it made its way into the Creative Energy Homes, which was the very first picture I've shown you there. So the Creative Energy Homes is a showcase of 7/8 houses of homes of the future, as we call. They're sustainable homes for various aspects. They do different things. They have different materials. They're sponsored by different businesses. For example, the one at the top there that you can see is called the BASF house. It's sponsored by BASF and designed to passive house. It's a pretty comfortable house with very, very low energy needs. The bottom one is the Nottingham house after it's built back in Nottingham. I will show you a bit more about it. The Creation Vanish Homes has other houses by Mark Group, Eon, Tarmac, and David Wilson, which are always spread across. So we created a new road just for that. And now you're going to see some pictures of the house realized on site against some of the sketches the students made right early on. Isn't it a beautiful thing to see your design fully realized? It's a pretty small house, but it doesn't feel small. It's a house that feels very airy and bright. You can see a picture here, the idea of interactive no living, that the kids and the parents are talking and chatting or food's being cooked. Is a very the ceiling height is really low because we had the limitation on the height, yet it feels bright and airy. You can see some sensors on the wall there, and you can see the PVs here. You can also see an electric car there. The reason for that is because we have been using it, the excess energy from the roof, to power cars. Some more images of them being constructed. If you are really interested in the science, I left some papers at the end that you can read on your own time, which are all about some of the scientific analysis and what has been achieved. You can also find the whole housing design available in this book that is available online, not just this house, but all the ones that took part in the competition. And about 10 years, well, 6 years after the house was fully built and finished, there was a big piece on the House Build magazine because the UK decided, and the UK government decided to stop pursuing zero carbon housing. And this piece was made in the news because actually it was saying if students could do this so long ago, why can't the UK industry deliver now? And the students, there's a picture of them on my birthday on site in Madrid. They went to work for some really big businesses, and they are, we're still in contact. It's still a really big group of us. So some articles for you to read, and also some articles around the charging and discharging capabilities that we stored there. So the excess energy can use for powering cars, which I'm sure you're going to be thinking about in the near future. Now, to find out more, there's lots of videos online and there's some articles as well, so some links there in the presentation. And obviously, you can also ask me questions. Thank you.
Thank you so much, Professor Lucelia, for the wonderful and the insightful session. Uh, Time to move for the Q&A. I can see some questions in the Q&A box. Wait. But
You can
already
see.
Nora Yuri has answered some of the questions, but still, for the visibility of all, I would like to address all the questions. So, which areas within sustainable design are expected to grow the most over the next 5 and 10 years? And he replied, climate resilient design, building performance, and retrofitting buildings. So,
Yes.
Professor, do you wanna add something to it? You wanna comment on it?
Yes. So
Anything
let
more?
me expand. Let me expand a little bit on that. Iveta, right? I think. So sustainable design is a big topic now because we all have to respond to climate change. Most countries have signed up to being carbon neutral or zero carbon, many by 2050, which is tomorrow for this kind of really big target, right? So that's very soon. Now, the areas that are, if you are a designer, an architect who can design sustainable housing, so this is housing there or sustainable buildings in general, these are buildings that have lower impact on the environment and require less energy, you absolutely are very much in demand professional, because we can't just produce energy to resolve the crisis, that produce green energy. That's a big part of it too, but we have to reduce the need for energy in the first place. We have to reduce the impact that everyone has on the environment in the first place, because we can't cope with just continuing to have the impact and then trying to mitigate it or offset it. So design is a really big part of sustainable design, as in the actual thinking across walls and so on. If you are working in the field and you've got developed expertise, being a passive house designer is a very big hit too. You will learn passive house if you come to the course. You can go on to continue the training to get a full certification as a certified passive house designer. If you do that, you have a full understanding of physics of building design, and again, you're way ahead of the crowd. Then the next aspect I would say is really important is thinking of the whole life cycle, because when we talk net zero carbon, we're not just talking about design, and we're not just talking about materials, we're talking about the holistic thinking all the way from the beginning of your conceptual design, then the construction, the maintenance, the end of life, and thinking through that. And as Yuri mentioned there, resiliency mentioned. So thinking through that, they actually, I'm occupying a house that is 140 years old and is still a house that is fully functional. So I would expect you to want your buildings to be occupied in 100 years' time. And for that to happen, you have to be thinking about the future. So how the future looks like, how are people going to work? How can my building be adaptable, flexible? How can my building respond to the needs of the people 100 years from now? So that makes your building sustainable, but also very resilient to the future. And another big area, I think Yuri has put down retrofitting there. So that essentially reusing existing buildings. So rather than just starting from scratch all the time, sometimes it's impossible not to start from scratch, but most of the time it would be beneficial for you to reuse what already is on site. And that by that I mean, rather than going extract earth again to start making bricks from scratch, and then you have to heat up the bricks, which use a lot of energy, then you have to transport them to site, then you have to get people to site, they're going to build the walls, and they're going to be a lot of waste. So all of that could be avoided if you could reuse a wall that is already in place, if you could modernize the buildings. But in order for making that work, you have much more constraints because you're working within an existing element. So it's a very difficult challenge, but one very important, particularly in the UK, where most of the buildings we inhabit today, and they will be inhabited in 2050, already exist. So does that answer all your questions, Sveta?
Yeah. Thank you so much. And the next question is, what technical and software skills are most valued by the employers in this field today?
So
And Nuri has, sorry?
yeah, I was gonna say Yuri has mentioned Beam,
Yeah,
but
there are
in particular,
different levels of technical skill and software we use in the industry. Generally, BIM is common for the construction industry, but softwares are evolving at an unprecedented rate because of AI. Therefore, new softwares are coming out or as add-on tools. Your software skills are valued based on what you are contributing within the team in construction project.
I
Thank you,
think
Nuri, for the answer.
so. Yuri's response is talking more generally about the construction industry, and
Yeah.
Beam and everything that's attached to Beam is very important. But I think you're talking about, the question is more about the area in particular, sustainable design, isn't it? In
Yeah,
sustainable
technical and the
design,
software skills mostly
yes.
valued by the employers. Yeah.
So the
Okay.
currently the most important building design software, the one that is most widely spread, is called
Hmm.
ISVE. That is Integrated Environmental Solutions Virtual Environment. So Integrated Environment Solutions is the company that makes it. The virtual environments is the software that enables us to model a building and fully test it. So by doing that, what we're doing is we're producing a digital twin of the building that represents what the building is looks like, feels like, and other characteristics of the materials or the occupancy. And then we run that simulation in order to give us for example, a performance. So it might say, I'm building a house in Kerala, and this is how the house looks like. You build your model. This is how people are going to occupy. It's a family of four. They stay at home most of the day. They go to work most of the day. Think about those aspects. You think about the materials, you plug the climate in, and then you ask the software, would my house be comfortable in these conditions? And the software will run several hundred calculations and give you an answer. Say, actually, it may be comfortable for 20% of the time. And then you say, oh, maybe I could improve it then. Let me go back and maybe put some shading on. And you add some shading onto the windows, and then you run a simulation again. And then it might tell you, actually, now your house will be comfortable for 67% of the time. So these are really useful skills using those softwares, because it can enable you to do a lot in a little time without the impact of actually building in real life. So we teach IES because it's the most widely used in industry currently, but we also have the facilities and teaching that you can access for Energy Plus, which is a similar type of software, but is available freely, so anyone can download and use. We also use TAS, which again has a dynamic simulation model that's something similar, and a software called Sapphire, which is a plugin to SketchUp and Revit. I guess most of you are familiar with SketchUp or Revit. So Sapphire is a plugin that enables you to look at building performance from a comfort and energy perspective. If you use Revit or SketchUp, I actually encourage you to give it a try. It's really easy to learn. We use a lot for early design stages because it enables you to get answers really quickly, while the dynamic simulation softwares that I mentioned before will take you more skills and take you a bit more time to get yourself through the different simulations and etc. So I'll encourage you to give it a try. Sapphire now, because actually if you use SketchUp and Revit, you can learn it really easily.
Thank you. The last question is, are students able to work on live industry projects or placements during the course?
So all the design sites we use are live. So we always use sites. So for example, the house you've seen, he was designing the course. It was a live site. The site in Nottingham where the urban setting, as I've shown you, actually is built now. Not exactly the same house, but it was influenced by the house that we use here, because we always work with either locally or across the UK with real clients, real councils on real sites. And that goes across all our postgrad courses. Often these people will come into studio with you. So when you do a studio review, you might actually be talking directly to the client, which gives you that edge, because it gives you that constraint of talking to people who are, going to be asking you difficult questions, or might be saying, actually, I can't afford that, think again, which is great. I think part of the learning. We'll take you to the sites. We do a few trips and site visits, so you can go and visit them and see them and experience them. Often you get the constraints of coming from the client, so you might get a whole brief that is a professional brief, not just the one that we produce, alongside the brief for learning. And many of the students do a placement at the end of the masters. So the masters will run from September to September, and you have your student visa, which enables you to work part-time through that period. And you also have your student visa beyond that period into January. So between September and January is a really good time to do a placement. So after you finish your dissertation over the summer, and before you have your graduation in December. And doing the masters also give you access to a graduate visa, which enables you to stay in the UK and work for 2 years without having to have a job lined up. So you can have the graduate visa and stay and look for a job, or do several jobs that don't necessarily give you a visa until then you decide whether you want to apply for a job that would sponsor a visa for you, or you decide to go back home after learning more from the experience.
Thank you so much for such an interesting and very informative session. So, time to wrap up. There will be I I believe we have answered all the questions. And thank you so much, faculty, for joining the session. Thank you so much, students, for joining the session. Thank you
I
so much a lot. Wishing you all a less good and for the restful day ahead.
If anyone has any questions
Yeah,
beyond here, and or they might not want to ask on this forum, they can drop me an email. My email is at the end of the presentation, or you can
yeah,
find me online. You can find Yuri online as well, that works directly with me, who's just been to India to meet some of you. So yeah, just drop us a note. We'll be very happy to answer anything about the course or about sustainability. I'm here for you.
yes, yes. Thank you so much, guys. Thanks a lot.
Thank you. Have a good
Thank you.
day,
Bye bye.
everybody.